Welcome to a new episode of Minds Between Languages. Today we are delighted to bring you Dr. Laura Babcock, who will be discussing various aspects of the neurobiology of simultaneous interpreting. Welcome, everybody, and Laura, what a treat to have you here. Thanks for joining Minds Between Languages.
Thank you for inviting me.
It is definitely our pleasure. So let's get right into it. We're going to be talking about the neurobiology of simultaneous interpreting. And I guess a fair initial question would be, how do you even study the interpreter's brains, and which are the tools, the techniques that you can use to do this, and what can you learn from them?
It's not that we're going to cut people's brains open, right? We want the interpreter to still be able to interpret afterwards. So we're definitely not doing any kind of open brain studies on interpreters.
That's reassuring.
We're making use of a lot of tools that allow us to look non-invasively at the brain. And the one that's probably the most commonly used is something called magnetic resonance imaging, or MRI. And this is in use in medical kind of practice in a lot of places, right? So if you have a problem with your back or your knee, you might go in and have an MRI done to find out what's going on inside, that area of your body. And we instead use it to look at your brain and see what's going on in your brain. And we use it in two different ways. So the first way is the same way they do it in medicine. So just look and see what's the structure. And so we call this structural MRI. And so then we can look and see, what does the brain look like? We can kind of map out the different parts of the brain, the different types of brain matter, right? So we have white matter and gray matter in the brain. We can separate them out and look at them and compare them between people or between groups. The second way we use it is called functional MRI. And here we're actually looking at kind of real time what the brain is doing. And specifically, we're looking at kind of a measure of blood flow. So where is blood going in the brain, with the idea that the parts of the brain you're using are the parts that are actually, using a lot of blood at that time. So for that, we have somebody kind of do a task. So they might need to do a memory task, or a perception task, or an interpreting task. We have them do that in the scanner, and we look kind of second by second or millisecond by millisecond where the blood is going in their brain, and get an idea of what parts of the brain, what regions of the brain they're actually using during that task.
That's fantastic. It's so different from the way in which the field has progressed so far. I mean, thinking about the cognitive aspects of interpreting. And if you think about this, I mean, there's a long tradition with different tools and techniques and methods and theories and frameworks. The interpreter's mind, let's call it, has been a focus of research for decades. And actually, I even dare say over half a century right now. So we've learned a lot by exploring this without looking at the brain. My question would be, Laura, what do we gain by actually delving deep into the biological intricacies of the interpreter's inner world?
Yeah, it's a great question. We've gotten very far with kind of not using these big tools, these big medical tools. So why should we add this now? I think there's an aspect of it that's just cool, right? There's people who, you want to know what's going on in the brain. You say, oh, I do brain research. It's just cool to look at it. But I don't think that's going to get you the money to actually do it. And it's not a really good enough reason to put somebody in a magnetic resonance imaging scanner or whatever method you're using. So we need to have more reason. So I think the first reason would be that behavior alone doesn't tell us everything. It can hide things. We don't really know what's going on. And so a great example of this comes from the literature on bilinguals and Alzheimer's. So what that literature found was that bilinguals, they would go on looking like they were fine. They weren't showing symptoms of Alzheimer's. And then when they had a scan, their brain had deteriorated much more than a monolingual counterpart. So that monolingual at the same kind of progression of these behavioral effects had much less deterioration in their brain. So there's things that are going on that behavior can hide. And so we really need to look in the brain to see what's going on. So one big question in interpreting research that I think that neuroimaging can help out is this question of directionality. Which direction should you interpret? Should you interpret from your native language or into your native language? And what are the reasons? So of course, we've looked at that, kind of looking at output and maybe some other processes, but we can also look at it with neuroimaging. And so put somebody in the scanner, have them interpret in both directions, and then see which one was more difficult. And so this is actually one of the big questions that early neuroimaging studies in interpreting looked at, was which direction is kind of more effortful. And what they found was that it's more effortful to interpret from your native language into a non-native language than vice versa.
That's fantastic. Now, this is on the assumption that increased patterns of brain activity, let's say hemodynamic levels, are directly related to effort. So, I mean, underlying what you're saying is this idea that the greater the activity, the more costly it was. Is it always like that? Is it necessarily the case? Is it a one-to-one relation that more activity means more cognitive taxation, let's say?
No, I don't think that's always true. It's something we have to be really careful interpreting, because we're not having kind of a direct access to what's going on. We're going, through this level of looking at blood flow. And so we don't know. And I think also there can be differences of different patterns, right? So you might not always see a difference in blood flow, but different patterns. And if we look at instruction, looking at the size of brain regions, this is a big question. We often think, oh, bigger is better. But it might actually be that smaller is better, and that it's not a linear pattern, that there might be some more recent research has shown that it's kind of a U curve. So when you start learning something, you start increasing volume of areas, and then as you become an expert in it, or as you get much better at it, more experience, you might actually start decreasing your volume, kind of pruning away. So yeah, we have to be careful not to assume kind of this one-to-one or even a linear relationship when we're looking at the brain, which makes it a difficult and fascinating area to look at, right?
It's fantastic, and it's also interesting to see that these complexities and the lack of linear one-to-one associations between structure, function, and behavioral output. It's not that we are just unsure in the subfield of the neurobiology of interpreting. This is symptomatic of cognitive neuroscience at large, isn't it?
Yeah. This is nothing special about looking at interpreting or the neurobiology of interpreting. It is definitely a kind of a field-wide aspect, which means that as somebody who's in this research, you really need to make sure that you're kind of aware of what's going on outside of just the one area that you're studying. But yeah, but it also means you can take advantage of all that other research that's been done and apply it.
Absolutely. So about this area, is that the right term for it? When we talk about the neurobiology of interpreting, is it a subfield? Is it a full-blown framework? Is it an emerging field? Is it just a collection of isolated papers? What is the status of this, Laura?
Yeah. So I mean, it's not a full-blown subfield. I don't think I can state that. I would like to think of it as an emerging area, but it might just be a collection of papers. It's not. It hasn't been widely kind of studied yet. 4 years ago, Alexi Hervé-Edelman and I, we put together to kind of a review on the neuroimaging research in interpreting. And for that, we looked at 11 published papers. That's what was available 4 years ago, 11 papers. So that really does sound just like kind of a handful. But I think there is momentum in this field, more interest. And so I'm hoping that it's kind of an emerging field. There are some clear barriers to this becoming a kind of a full-blown subfield. It's expensive to study, to use these methodologies, and so we have to, actually get the funding for it, and then we also have small sample sizes. There's not that many interpreters in comparison to just the general population. So I think those are some barriers that we've had to have it progress a little bit faster.
Fantastic.
But people are getting interested in it, and all interpreters are going to jump in the scanner soon.
Yeah, especially after this interview, I hope. And you were mentioning the capacity that we have nowadays to track differences between the brains of a certain population or group of people and others. So what specifically out of this handful of papers that are available out there would you say is distinctive about the interpreter's brain relative to those of multilinguals who have never practiced interpreting?
Yeah, so unfortunately, when we look at these papers, when we look just at kind of the structural papers, so looking actually what the brain looks like rather than kind of what it's doing when it's interpreting, we have 6, 7 papers we can look at, and there's not much consensus between them. So it's really hard to say, oh, this is an interpreter's brain. And there's kind of not consensus in the locations, and there's also what we talked about before, this difference in is bigger better or is smaller better. So we have some places where when we compare interpreters to translators or to other multilinguals, we see that they have larger volumes in certain regions of the brain, and other papers show that there are smaller volumes, and both are saying, oh, that's because the interpreters are better. And so it goes back to what we discussed just a few minutes ago, that it's not linear, but I think we don't have enough information right now to fully track that for interpreters. But what I do want to say also is interpreters are a heterogeneous group, multilinguals are a heterogeneous group, and so there's a lot of individual difference in there, and there's lots of ways of being a multilingual, and there's lots of ways of being an interpreter. So that adds a lot of variability into our data. But we want to talk about some specific regions. I think people want to know something that's different. We found a lot of kind of differences in this area called the frontal pole. That's kind of all the way up here at the front. And this is often involved in multitasking. And so I think we can see that's something probably that simultaneous interpreters are doing. There's a lot of multitasking during the interpreting process. And then the other region that kind of came up in multiple studies, not all of them, was the left inferior parietal lobes. That's a region that's kind of, I'm on my left side, good, back here. It's not quite clear what this role would be. It doesn't have as clear of a relation, but that's one other region that might kind of show a difference between an interpreter's brain and just a regular multilingual's brain.
That's fantastic, and yes, it's hard sometimes to tell the difference between a finding, a fact, an empirically supported hypothesis, right? I mean, it's like we don't have sufficient evidence to really tell the difference between one or the other, if that's ever possible. But there's yet another interesting question that may complicate things a little bit more. You've been very, very, very clear and cautious to always speak about differences. This involves this is different, but it would be, one might be tempted to say, oh, if there's this difference in brain size, brain volume, or even brain activation in the interpreters relative to the multilinguals who are not interpreters, it must be because the interpreting task triggered those changes. But that's not necessarily the case. It may well be that people who thrive in the interpreting field are those who have these pre-existing brain differences. So do we have any way of disentangling this issue, Laura, or what's your personal position in this debate?
Yeah, I mean, this is kind of an age-old question, right? Nature versus nurture, and it's definitely present in looking at interpreting research. And it is really difficult to pull these apart, particularly if you're just making what we call a cross-sectional comparison. So if you're just comparing interpreters to multilinguals and just looking at them one time, and you're assuming that whatever difference you see is because of their group membership. So one way of really pulling apart this difference is to do what we call longitudinal studies. So tracking the same people over time, and we can actually see kind of a difference. And if we compare them to another group at the beginning that's not going to do interpreting, then we can see if there are any kind of pre-existing differences between the groups, and then what happens over time. So there are, of the studies that we reviewed, there are three that were longitudinal. And so those did show some differences in brain structure between when the students started and when they finished. This was all students learning to do interpreting, so during their kind of education period, normally a master's. So there is some evidence to suggest that there are some differences that come about because of your interpreting experience. But we are nowhere near being able to kind of really expand on those. And I think this is one area that really needs a lot more research, is more longitudinal studies, and not just of those early years, but also continuing to look at people as they enter the field and gain more experience.
I couldn't agree more. And then again, we're talking about interpreting, and we use this single noun to refer to it, and it may sound as if we're a monolithic skill or activity, but it's such a complex amalgam of so many skills, sub-skills, processes, and so on. There are two in particular that I'm interested in, and which, if I understand correctly, draw a distinction between, which are the notions of cognitive control and language control. So my questions for you, Laura, would be, first of all, what are those two domains? How are they different? And what are the roles in simultaneous interpreting?
Yeah, I mean, this is a difficult question too. So if we're talking about language control, then I think we're really talking about how an individual controls the languages that they have, and that might be one language. So it might be that we're talking about kind of controlling which words you select, which grammar you use, things like that. But clearly, when we're talking about bilinguals or multilinguals and interpreters, we're talking more about selecting the right language and making sure that you're producing language in the language you intend to be using. Cognitive control, when we use this term, we're talking about, I don't want to call them higher level processes, but maybe more general processes. We often refer to them as domain general. So an attention process, how do you focus your attention, or avoiding interference process. And so I think that these two are probably, language control and cognitive control are somewhat overlapping. I don't know if I would say that language control is completely just a sub part of cognitive control, but there's definitely a lot of overlap there. But I think it's pretty, maybe I shouldn't say easy, but if we think about the interpreting process, that of course interpreters need to control their languages, but that's kind of an essential part of interpreting, that you produce the right language. And that's particularly interesting in interpreting, because previously we've always assumed that a bilingual, I shouldn't say assumed, but there's been kind of hypotheses that the way that a bilingual produces language in the right language is by inhibiting the other language, by kind of suppressing it. But an interpreter can't do that. They need to be able to have access to the language they're listening to, that they're interpreting from. And so I think this gets to be a really interesting concept in interpreting. How do you control a language, produce language in the right content, in the right language, while also having an incoming speech stream in the language you're not supposed to be speaking? So I think when we're looking at language control in interpreter, we're really interested in how do they do this kind of selective control of the languages. Cognitive control is also really important, though, because, as I said, it's domain general, and interpreting is such a broad kind of thing. You're doing a lot. There's a lot of memory processes. You need to focus attention on certain things, different levels of speech, and monitor your production. So I think cognitive control really comes in those aspects when we look at interpreting, figuring out thinking about memory, attention, monitoring processes, then we're looking at something that we call cognitive control.
Absolutely, absolutely, so clear. And a very interesting thing about everything you're sharing with us today, Laura, is that each utterance, each answer you're giving us is sort of it lives in this hybrid space between the cognitive and the biological, right? Even the very title of what we're discussing here, the neurobiology of simultaneous interpreting. There's a field which is decades old in existence that has been exploring aspects of simultaneous interpreting scientifically, different approaches. And now we have this cognitive neuroscience view of things. You would expect that a neuroscientific view of interpreting should be a perfect harmonious conflation of both worlds. Now, would you say that there is sufficient dialogue between classical standard interpreting studies and cognitive neuroscience, or is it something else?
Unfortunately, no. I don't think there's enough dialogue between the two fields, and that partially might be biased by the way I came into the field. I came in through such a cognitive neuroscience perspective that I wasn't even aware of this kind of parallel field and all of the literature there. And so that might partially be, just me. I don't want to claim that's true of every kind of researcher looking at the neurobiology of interpreting, but I think that there has been too much of a separation, at least in probably the last 15 to 20 years. I know we go back to the 1980s, there's this famous the Trieste Symposium, and it was brought together. It was so interdisciplinary with psychologists and practitioners, and I think Ike was there, and it was really great. But I didn't feel that in kind of my education in cognitive neuroscience, and I think one of the biggest problems is that we publish in different areas. So, right. And we present in different areas, that people are really going to different conferences and they are publishing in different kind of areas, and that we're not looking between those areas enough. So I think things like this kind of being aware that there are these other fields is really great to start to change that. And I do think that there is some kind of advance going on in this. For me personally, I'm now situated in an interpreting and translation studies department or institute. So I am fully immersed in kind of the interpreting studies culture. So for me personally, there's been a huge change, and I think kind of more cross dialogue needs to happen to really grow the field, or grow from our collection of papers into an emerging area.
Absolutely. And speaking of growing the field, looking forward with this experience and the insights that you have on the status of the field, on the beginnings and the challenges and the possibilities of the field, let's look forward a little bit. So if you had to single out one or two, maximum two outstanding questions for the next few years of research into the neurobiology of interpreting, what would those be?
All right. Well, just maximum two is, I think, it's very constricting. So I'm going to start with one that I already mentioned, and I'm not going to count it as one of my two. And
that's cheating. That's cheating, but that's okay.
I already mentioned it. So just reminding everybody that I mentioned longitudinal designs. We need to start kind of looking at people as they progress and getting that information. But that's not one of my two. So if I'm looking forward to next year's, one of the big things I think I'm hoping is going to happen is that we start looking at people's brains while they're interpreting. So I didn't go into it when I started talking about MRI, but you're not allowed to move. So if you've ever had an MRI, you probably know you have to lay in there and be very still. So it makes it very difficult to interpret, right? If you actually have to speak, that's a lot of movement. And so studies in the past have gotten around this by having people maybe just interpret in their head. But of course, that's very different. You're not hearing your own voice, so you don't have kind of that aspect. Or by kind of having them interpret in very small segments and then stopping the machine in between so that you could interpret. But then it's kind of choppy. So it's not looking at the full process. But there have been some advances in the technology for imaging recently that I think will allow us to actually have people start to interpret while in the scanner, and then we can really see the process that's happening there. So that's the first one. And then the second area that kind of I think needs to be investigated in the next years is different types of interpreting. So today I know the title was Neurobiology of Simultaneous Interpreting, but I think we need to kind of go beyond that to other types of interpreting. And one area that I'm really interested in is looking at public service interpreting or dialogue interpreting, because there's a really different profile. Now people, instead of just always speaking in one language, they're going back and forth between the two languages. And so that's an extra level of control. Kind of they're managing also what language they're producing into rather than kind of knowing always I'm sticking in this language. And so I'm really interested in looking and seeing that, how that looks in their brain, and if that has any effect on their brain structure.
That's phenomenal. And we'll certainly be looking forward to your contributions for those questions. And if I may ask one more thing, being a researcher is no easy task. It can be challenging, daunting, perhaps even more so if you're working in an interdisciplinary field, and perhaps even more so if it's so, let's say, not as full-blown as other interdisciplinary arenas that maybe have a longer standing tradition. There may be people in our audience that just say, I agree with you and say, hey, it is cool to look at the interpreter's brain, and they may be interested in pursuing a career there. Which are the pieces of gems of knowledge? I mean, a couple of career lessons that you've learned and that you yourself, perhaps, Laura, would have appreciated to have when you were sort of forging your own story in this field.
Yeah. So advice that I always give to people who are considering doing a PhD is that you need to be passionate about the topic that you're researching. As you said, research can be hard. Research can be amazing, but it can also be really hard. And there's going to be times when things don't work, when you just found out somebody already did the study you want to do, that your participant doesn't show up, or you're just kind of stuck. And I think it's really important to really feel strongly about the topic that you're researching. It's much harder to get yourself motivated when you're kind of like, I'm not so interested in that. So that's kind of my first standard piece of advice. You have to be really interested in your topic. But beyond that, I would say, given, as you said, it's just such an interdisciplinary field, one kind of piece of advice I would give is to read broadly. Really, I think I didn't do that enough, to really look at all of the different aspects and search out literature and sources beyond whatever your kind of specific areas or your program is in. And then maybe the last piece of advice, I probably have more advice than this, but I'll stick it to this, that everything takes longer than you expect, that there's going to be a delay, somebody's not going to show up, it's going to take you longer to program that task, everything's going to take longer than you expect. So work in some extra time into your time schedule, your timeline you're working on.
That is great advice. I could have used it myself back in the days. So thank you very much for making this available for our audience, and thanks for sharing your time, your expertise, your ideas, Laura. It was a pleasure to have you here, and you'll always be welcome back to Minds Between Languages.
Oh, thank you. It was a pleasure to be here.
Till next time.